Hi everybody, today we're going to look at parallel and perpendicular lines and how we kind of calculate the equations of parallel and perpendicular lines given a bunch of information. Alright, so let's kind of get going. So first of all, parallel lines, key part of this is they have the same gradient. Alright, so that's the first bit. Parallel have the same gradients. Okay, so if you've got trying to find a line which is parallel to another line passing through a specific point, then the key part of doing this is we need to find what the gradient is of the current line, and ideally where it crosses the y-axis or something to that effect. All right. So when we're looking at this example here, we're using y equals mx plus c as a format that we're familiar with. And again, if you're not quite sure what that is, then please look at another lesson which is about the equation of a line taking that format, where m is the gradient. So that's this value here, number 3. So the gradient of the line is 3. So the gradient of the parallel line, it must also be 3. So that's the kind of reason we need another line to give us that piece of information. And this line passes through 0, 8. All right, so that line passes through 0, 8. So m is 3. And then because the line crosses the y-axis at 8, all right, that tells me that c is 8 equals 8. All right, because the idea of is you're thinking about y equals mx plus c, where m is the gradient and c is where it crosses the y-axis, and that 0, 8 there, which is on here, 0, 8 there, that tells me the coordinate of where it crosses. So it must cross at 8, so therefore c must be 8. All right, so that's where that kind of comes from. So find the line parallel to this, so we've got gradient of 3, and it passes through that point, and that's where it crosses the y-axis. So I've got m and I've got c, and then I just need to put it together. So y equals 3, that's the gradient, plus 8 where it crosses the y-axis. All right, so I need to be familiar with what y equals mx plus c is and what those things represent. All right, so in this case, m represents the gradient, and again, c represents where it crosses the y-axis. And in the question, it tells me exactly that. All right, so that is my answer. All right, so let's have another look at one which is slightly different, a slightly different format. I'm trying to find a line which is perpendicular to it. All right, so if we line which is perpendicular to it, first things first, it needs to be in the format y equals mx plus c. But the problem is, of course, at this point, it's not. It's got a value of 2 in front of it. All right. So the first thing I need to do is divide everything through by 2 to get rid of this 2 at the front. All right, because it needs to be y equals something x plus something. All right. So dividing it all through by 2, I've got y equals 4x plus 1.5, which is half the 3. I'm not really bothered about that one that much. I'm really focused on the 4 because that gives me the gradient of the line. All right. So that'll give me the gradient of this line. But I want the one that's perpendicular to it. All right. So the one that's perpendicular to it is, it's not going to have a gradient of 4. It's going to have a gradient which is the negative reciprocal. All right. So please look at, again, at another lesson when we talk about parallel lines and working out what the reciprocal is. There's a few other lessons in relation to that. But the negative reciprocal is you change the sign. All right. So it's going to be minus. And then you flip it upside down, so it's going to become 1 over 4. All right, so the perpendicular gradient is minus 1 over 4. All right, so that's my m for my new line, the one that's perpendicular. And it also crosses through 0, minus 2. Well, again, because it's 0, minus 2, that tells me exactly where it crosses the y-axis at minus 2. So my value for c over here is minus 2. All right, so I've got m as minus a quarter and c is minus 2. And if I just plug those into the y equals mx plus c, so this lot here, then I've got y equals minus a quarter, that's m, x, and then it crosses the axis at minus 2. All right, so therefore that's the line which is perpendicular to it. Okay, all right, there's another part of this which we're going to look at now. So I'm going to continue where maybe it's not quite as generous in terms of the coordinate. All right, so if you look at this coordinate here, you'll notice this is not on the y-axis. All right, that is not on the y-axis, which just makes our life a little bit more awkward in terms of how we do it. All right, so I'm going to go through that process as well, because, well, like I said, it's just a little bit more complicated. So first of all, it's parallel to this. All right, so starting point is we're looking at this gradient. It looks like y equals mx plus c to me. It does. So therefore, I can take the fact that the gradient is 2. All right, so that means the gradient of the parallel line, the one we're after, is also 2. All right, it's also 2. The problem here is that we don't have where it crosses the y-axis. We don't have the value of c, which is what we had before. So we've got a little bit more work to do. So we're going to use this coordinate that we've got, and we're going to use this value of m that we've got. And actually what you're going to do is going to plug those things into here. Okay, so I've got a y, which is the 6, I've got m, which is the 2, and I've got an x value, which is the 1. All right, so I've got those three values there, and that's going to leave me with c. All right, so by just plugging those three numbers into here, I should be able to figure out what c is. All right, so let's have a look. So y equals 2x plus c, so we put the 2 in. And then we know that we've got a value of x as 1 and y is 6 to find c, so we're going to plug those in there, so hopefully you can see that. You've got your y value of your coordinate equals mx, so 2 times 1 plus c. All right, so 6 equals 2 plus something. All right, well, if you just rearrange that a little bit, c must be 4. All right, and hopefully you can see that from that. So 6 equals 2 plus something, so therefore c must be 4. All right, so I've got my point where it crosses the y-axis, so it crosses the y-axis, so that's that number there. And I've got my gradient there, so I plug those into the y equals mx plus c into this bit, and that's going to give me the equation. So I've got y equals mx plus c, so the m and the c go into the equation. And you'll notice in every single case, I always have the y and x, they have to be there. All right, it's the m and the c that I needed, which I've now got. Okay, so that is the solution to that one. So if you're doing anything that involves parallel and perpendicular lines and you're given a coordinate or a grade, or maybe not the gradient, then they're the things that you need. You need some coordinate and you need a gradient for this to work. Otherwise, you're not going to be able to do any of this. All right, so I'll say it one more time so we're really clear on it. You need a gradient or some way of figuring out the gradient, i.e. an equation in this case, and a coordinate. All right, if you think about it logistically or think about a graph, if I ask you to figure out a graph, I'm going to have to know where to draw it, and I'm going to have to know how steep it needs to be. All right, if I've got those two pieces of information, then I should be able to plot it or glean from it the equation of the line. All right, please do have a go or visit maths-school.co.uk. There's a bunch of questions which will help you kind of practice on it. But of course, if you need to revisit the video on this topic or any other topics, then please just kind of look those up. All right, but thanks for listening.